Dylan. 2.4, we're going to be working with operations in scientific notation. You know how to convert between the two, standard form and scientific. Now you have to be able to do the operations. Okay? To add or subtract numbers in scientific notation, the numbers need to be in the same base or written in standard form. You cannot add or subtract them if they have a different base. Okay? So for example, the first one we have 3.1 times 10 to the 8th, and then we have 10 to the 7th, and we have 10 to the 8th, okay? So we have 2 that are to the 8th and 1 to the 7th. In order for us to add them, they all need to be in the same base. So I'm going to switch this. I want this to be times 10 to the 8th also, right? Yep. So since I made this number bigger, this one has to get smaller. 3, 3, 8. Times 10 to the 8th, okay? So we're going to add those up. 3.1 times 10 to the 8th. And this one is 0.338 times 10 to the 8th. And then our 1.1 times 10 to the 8th. They all have to have the same power, all right? Now, I like to fill in zeros as placeholders on the rest of the numbers. So when I add up my thousands, I have 8. My hundredths, I have 3. My tenths, I have 5. And my ones place, I have 4. Is that still a number between 1 and 10? Yeah. So we're done. I just write times 10 to the 8th. Okay? That's one way to do it. The other way is to put them all in standard form. So I would go 1, 2, 3, 4, 5, 6, 7, 8, right? It takes more time. That's 310 million. Okay, 7 places would be 1, 2, 3, 4, 5, 6, 7. Oh, I'm even off one more. Hold on a minute. 1, 2, 3, 4, 5, 6, 7, 8. What do you have 9 where?
You have up top, you have 9.
No, you see that.
1, 2, 3, 4, 5, 6, 7, 8.
1, 2, 3, 4, 5, 6, 7, and that's an 8. 1, 2, 3, 4, 5, 6. I'm off one. I'm off one.
Exactly. I said you had 9 up there and 7.
1, 2, 3, 4, 5. This.
What is he talking about?
Okay. And then 1, 1. So that's 1, 2, 3, 4, 5, 6, 7, 8. What do you mean it's not even? Okay, so, and then if we put it back into scientific notation, it would be 4.538 times 10 to the 8th power.
That would seem a lot easier. Yeah, that would be a lot.
The standard form?
No.
It's up to you. I mean, you could have numbers that are like to the 28th power.
It's like counting in your fingers.
Sometimes it's easier to do it in standard form. Sometimes it's easiest to do it using exponential form. Okay, you do the same thing when you're subtracting. It needs to be in the same base. So I have to the 8th, and I have to the 7th. Okay? So if I'm going to subtract this, I'm going to make this 0.338 times 10 to the 8th. Again, if I'm going to make this number a bigger number, 8th power, this has to become one place smaller. So I have 1.1 times 10 to the 8th minus 0.338 times 10 to the 8th. I think it's very important to put in your decimals as placeholders. All right? So now I can subtract. I have to borrow all the way over here. So 10 minus 8 is 2. 9 minus 3 is 6. Oops, I got the wrong. 10 minus 3 is 7. times 10 to the 8th. Now what do you notice? Is that in scientific notation?
No.
Mason, why aren't you taking notes? Shut your computer, please. You need notes?
Yeah.
Here.
I had it.
I have an extra set. Here you go. Okay, so now to go back to scientific notation, what would this number have to be?
7.62.
Okay, so since I made this one place bigger, this has to be times 10 to the one place smaller, which is 7th. Okay?
Why wouldn't you just leave it at 10 to the 7th?
You could have converted it into 7th power, but you would have had to know that you were going to do that. It doesn't matter, as long as you have the same base. So in the next one, we have two different bases, 10 to the 4th and 10 to the 5th. Which one do you want to switch? You should probably make this to the 5th, right? Otherwise, you're going to end up switching it again like we did on the last one. So if this is going to be one place bigger, this has to be smaller, so it becomes what?
0.56.
Awesome. Times 10 to the 4th. I'm going to leave some room here. 0.56 times 10 to the 4th, or 5th, excuse me, now I switched it, plus 4.7, I'm going to put a 0 here, times 10 to the 5th. So now our bases are the same. We can add them up. So I get 5 and 2600ths times 10 to the 5th power. And that one's already in scientific notation. So we don't have to switch it. Okay, a lot of you have done this in your Moby Max already, and you'll be working on IXL too. Any questions on adding or subtracting? You need to make sure it's in the same base before you add and subtract. If you messed up and made this to the 4th, then you'd have to switch it back to the 5th when you're done. It doesn't matter which one you work it in, as long as when you're finished, you put it back into scientific notation. Mason, will you please shut your computer?
Yeah, I guess.
Okay, I would like you to take out your calculators. I do think yours is going to look different. Let me grab mine than what this says.
And 7%.
Okay, in scientific notation, E takes place of x to the 10th. Okay? Your calculator is going to say times 10 to the 10th, okay? If you have the one I have. If you have a different one, you might have this method where it uses E. So some calculators will use E instead of times 10. So calculator notation, if I want to put this in calculator notation, I'm going to replace times 10 with an E. So all it becomes is 7.5 E5. Does that make sense? You're just replacing it with an E.
Why?
Yes.
Where is it?
It's I just did it on ours. Mine says 7.5, like this one says times, I did it to different power to see, times 10 to the 10th.
Does it just look more organized? I don't want
Yeah, why is it, what's
You're going to need to know this for when you have if you have a calculator that doesn't have this button. Okay? So this one would be 3, and instead of times 10, you replace it with E, and then just negative 7. It'll do it for you. Wait till we do some examples, okay? This one got cut off. This one says 4.5 E to the negative 1. So we're going to put that back into scientific notation. So all we're going to do is replace this with times 10 to that power, right? So 4.5 times 10 to the negative 1. All you're doing is replacing E with times 10, or replacing times 10 with E. So this one becomes 5.6 times 10 to the 12. Okay? So some calculators might use that notation. Just be aware of that. Okay, next page. Now we're going to multiply and divide. Okay, multiplying and dividing. All you do is follow your rules of exponents. So we're going to multiply our bases. And then we're going to add them up, and we're going to multiply our front numbers. So we're going to take 6.4 times 3.2. I'll let you use your calculators if you want. It'll go faster. 6.4 times 3.2, and you get what?
20.48.
No.
20.48. Oh, we're dividing. Shoot. Sorry. Go back up. See, it's where it says divide. Divide first.
It's 2.
Thank you. 2 times, what do we do with our exponents when we're dividing? So we have 10 to what power?
10 to the 5.
Second.
We have 5 minus 3, so it's going to be the second. That one was easy. The next one we're multiplying. So I have 7 times 4.7, which is what?
You guys can do this.
32.9.
Okay. Times 10. What do we do with our exponents when we're multiplying? We have 6 plus 3, which is 9. Again, we have a problem. That is not scientific notation, so what do we do? Perfect. So this becomes 3.29, and then you have to add that to the exponent, so it's 10 to the 10th power.
When do we get our new seating arrangement?
Can we keep these seating arrangements?
Yeah, I actually kind of like this spot.
Okay, so now we're multiplying or dividing and writing our answer in scientific notation.
8.9.
You already multiplied it?
Yes.
Did everyone else multiply it? 1.86 times 4.8.
8.926.
8.928
Yep.
times 10. We have to add our exponents to the eighth. Awesome. Do you see how multiplying and dividing is easier?
Yeah.
Okay, so now if we do these ones, we have to divide. 3.67 divided by 1.17.
3.1.
Oh, that's a long one.
52137.
We should make that into something more user-friendly.
Yeah, but then that's not correct.
Yeah, exactly.
Okay, round to the nearest tenth on this one since it goes forever. So 3.14 times 10 to what power?
Don't talk about it like that. That's
So Tristan, what did you get when you subtracted your exponents?
Your second power.
To the second power. 10 to the 9th minus 7 gives you 10 to the second power. Okay?
Could we just do the sign? Pi?
Okay, you should be on page 54.
no, thank you. Toss it back to me.
Yeah, I got time on there.
Okay, so on the first ones it says to add or subtract and write your answer in scientific notation. So we have 4.2 times 10 to the 6th plus 2.25 times 10 to the 5th and 2.8 times 10 to the 6th. So your 4.2 times 10 to the 6th will stay the same. This will become 0.225 times 10 to the, if this became a smaller number, this exponent has to become bigger, so it's going to also be the 6th, right?
Yep.
That's really blurry. Plus 2.8 times 10 to the 6th. So now we add them up, 4.2, 0.2225, right?
Yep.
0.225, and then 2.8. When you add them, you get 7.225, and then your exponent stays the same. Okay? So when you're adding and subtracting, you need to make sure you have the same bases. The next one we're subtracting, we have the third, and the second. So we have to switch that one to the second power. So it has to become the second to the third, so it's going to be minus 0.10 times 10 to the second. So now we can just subtract our numbers. 8.5 minus 5.3 minus 0.1. So go ahead and subtract those. You get 3.1, and then your power stays the same, so it's 10 to the third. Any questions on that? Okay, now we're going to do a couple without that don't have as much help on that. Okay, so we have 1.25 times 10 to the second, 0.50 times 10 to the second, and 3.25 times 10 to the second. So do we have all the same bases?
Yes.
So just add them up. Add up your 1.25, 0.5, and 3.25. And you get 5 times 10 to what power?
The second.
The second, because it stays the same. Okay, on the next one, we have a power of the fifth, the fourth, and the second. Okay, so I would leave your 6.2 times 10 to the fifth, but if I'm going to make this the fifth, it has to get 1 point smaller, right? So it's going to be 0.260. I guess you don't need the 0. Times 10 to the fifth. I just added a 0 because I was going to do the next one too. But since it's subtraction, I'm going to do it in 2 steps.
This should make your 62 the 6.
Did I write it backwards? No, I have 2.26 on the first one.
Never mind.
Okay. You don't need these zeros. I added those. I was going to do the next one, but since it's subtracting, I'm going to do it in 2 steps. So I'm going to borrow. And I get 5.94, right? That's still times 10 to the fifth. Now I have this number. How many places do I need to move my decimal?
3.
So I'm going to have 1, 2, 3, right? So that's what I need to subtract from 5.94. And you can use calculators, I don't care. If not, you need to line those up. 0, 0, 1, 9. And then subtract them. Times 10 to the fifth power. Those of you not participating are going to struggle on this assignment. Questions on that?
No.
Okay, multiplying and dividing is easier because you just do your front digits and then add up your exponents. Or subtract them if you're dividing. So in the first one, 1.8 times 6.7 gives you what? 12.06, right? Times 10 to what power? 9 plus 12 is?
23.
Okay, now I need to put it back into scientific notation. So my 12 becomes 26 times 10 to the 22nd. Number 6 is division. 3.46 divided by 2 gives you what? Use your calculators. 1.73 times 10. You have the 17th and the 9th, right? So you have to take 17 minus 9, and you get 8th. Next one is multiplying again. So 5 times 16.9 times 10 to the 12th plus 6 is 18th. In scientific notation, that becomes 1 point times 10 to the 19th. Good. Last one is division. 8.4 divided by 4.2 is? Times 10. Subtract. What's 21 minus 14? 10 to the 7th. All right, these ones are easy. We're just going to use the calculator notation that they told us. So E is equal to times 10, right? So instead of times 10, you're going to have 3.6 E11. That's all you have to do is replace those. 7.25 E negative 5. What's the last one going to look like? 8 E negative 1. So those should be easy points on your assignment. You're just replacing these things, E and times 10. So now down here we do the opposite. This becomes 7.6 times, instead of E, good. And then 1.2 times 10 to the, and then 14 is 9 times 10 to the first. Question 15 says, how do you add, subtract, multiply, and divide numbers written in scientific notation? When you add and subtract, what do you need?
The same base.
When you add and subtract, you need the same base. And once you have that same base, you can add or subtract and then put it back in scientific notation. What do you do when you multiply and divide?
You add or
What rules do we follow? You're going to multiply and divide, and then you're going to follow rules of what? Exponents, yes. So if you're dividing, you subtract them. And if you are multiplying, you add them. Okay? Why do I have so many? Yes, I messed up on this one. Number 4 should have been 5.9381. I subtracted wrong.
Can you go down to the writing
Thank you.
thing?
The writing part?